So for the B vaccines, I guess the important thing is where is the disease. And a large proportion of disease is in babies and very early childhood, the first 2 years of life. So a B vaccine really has to target that age group to protect a large proportion of disease. But then there's also disease in other age groups, and there's a little bulge of disease amongst teenagers, for example. One of the very interesting questions about this organism, the meningococcus, is how it's transmitted. And we know for group C, the one that we've had a vaccine for the last decade, that if you immunise teenagers, you can actually prevent disease in all other age groups. So it's possible that with a B vaccine, if it can prevent transmission of the organism, it might actually allow protection of other age groups. But the question is, who do you have to immunise in order to prevent transmission? We knew for C it was teenagers, but for B it's less clear which is the right age group. I think if you look at the A, C, Y and W disease, the key questions are, can you, by immunising one particular population, as was with C, prevent disease in other populations? That's called herd immunity. So that's one key question. The other really is how to implement them. We know that in different countries there are different amounts of disease caused by the different serogroups, the A, C, Y and W. And depending on which country you're in, you might have a different policy for giving the vaccine to babies, giving it just to teenagers, or perhaps even not using it at all if you don't have any disease caused by those serogroups. For Group B disease, we clearly need more data in the clinical development programs about how well the vaccines work and, critically, how much disease they can actually prevent.